Today's topic is Introduction of Stereochemistry, and in this topic we will discuss about the basics of stereochemistry and the associated subtopics, the stereochemical concepts. So here the subtopics which we will discuss is about the chirality or molecular dissymmetry and chiral objects, achiral objects, enantiomers, and some example of these all subtopics, and we'll try to explain and try to learn how the chirality in a molecules affects their different nature of reactions during the course of different chemical synthesis. So here, after all the discussion of these topics, you will be able to learn about the concept of chirality and molecular dissymmetry, and will be able to understand the chiral objects. You will also be able to understood after this difference between chiral and achiral objects, and will be able to understand the enantiomers. So now we are going to discuss about the chiral and chirality. So here the chiral, which is a Greek terms, and the meaning of the chir means handedness. It means similar to the hands, two hands. So here, if in an object which cannot be superimposed on its mirror image, is said to be chiral. So here the property of non-superimposability is called chirality. Thus our hand are chiral. So if you see the left hand with respect to the right hand, so here you will see the left hand or right hand are dissimilar. They are not similar to each other, or you can check it out with by putting a mirror in between a one hand or palm. You will see your this hand is not similar to this mirror image. So once you will try to superimpose over this, so it will not be superimposed. So here the chirality, similarly in case of the chemicals or any compounds in any organic compounds, if this kind of conditions is comes, then that molecule is called as chiral. And if it is having a like carbon atom which is surrounded by four different atoms or groups, then that carbon atom is called as chiral center. So herely, similarly in many objects are also chiral apart from these examples. Here if you see in alphabets like R, F, J are chiral and A, M, O are achiral. So here we can see with this by putting a mirror in between these alphabets, so we can check it out whether they are superimposable or not superimposable. So you can see here like this R will looks like this R. So this is just the opposite of that. So once you will try to superimpose over here, so they will be not superimposed to each other. So similarly J, it will looks like this, and F, if you put the mirror here, so it will looks like this. So these type of compounds are chiral compounds or chiral objects. In case of if it is in a organic compounds, the similar condition comes, then that will be called as chiral. So here once you see in another alphabet like A, if we will put the mirror image in mirror, then it will, the mirror image will be looks like the similar. Similarly in case of M and O, so these are achiral objects. So here you can see the chiral objects are human hand, globe, shoes, etc. And there are a number of achiral objects, sphere, cube, buttons, and socks without thumb, etc. are achiral. So the chirality or molecular dissymmetry is the necessary and sufficient condition for a molecule to be optically active. So if it is showing the chiral, then you have to see there the need of to check whether that particular carbon atom is surrounded with the different type of atoms or groups once you are talking about a organic molecule. So molecular chirality and asymmetric carbon, here if we see how we can see this by taking the example of a carbon which is having a sp3 hybridization or sp3 carbon atom. So the four different atoms, if it is attached with that carbon, then this will be said as a chiral molecules, and the central carbon which is having these four different groups or atoms will be said as chiral center or chirality center. So the presence of chirality or chiral center usually leads to molecular chirality, because if the chiral center is there, then obviously the overall the molecule will be chiral. Such a molecule has no plane of symmetry, because you will not find any plane of symmetry or and exist as a pair of enantiomer. So you'll see that will be enantiomers, means mirror image of each other. Such a carbon atom is sometimes also referred to as asymmetric carbon atom. So you know, need to confuse with the chiral carbon or asymmetric carbon. So it is here, if you can see the example. So by this example, in a very simple, if this carbon is having four different groups, so once you will put a mirror, so then if you'll see the image of this, so it will looks like this. So once you will try to superimpose this in this organic molecules, so this is not going to be superimposed. So these are non-superimposable. So these are basically enantiomer, mirror image of each other. So here this is the simple example is given. So this is the derivative of methane, means we have to change the carbon with the hydrogen which is attached over here with the different groups. So here these groups might be like just WXYZ, this could be like OH, this could be NH2, this could be some carboxylic acid group, or this could be some another groups. If these are different, then this will be like a chiral molecules. So here also, if we see, there are different type of chirality can be also possible, like in case of allenes which is having the cumulative double bonds, means continuous double bond, like in case of alternate double bond, means after one carbon there is a single bond, then double bond. So but in cumulative double bond means this is in continuation. If like carbon, so that is having the double bond carbon, and again it is having the double bond carbon. Coming to this by taking the example of another, like in this you can see here, like this is the carbon is having like four different groups. One group is could be like a hydrogen, it could be some other groups. So here X, Y and W are representing uh, different atoms or different groups. So here this is like you can see here, this is the mirror image. If you will put here the mirror, so this will be Y is just the mirror image of this Y, and once you will try to superimpose to here, so these are not going to be superimposed. So non-superimposable, you can say the non-superimposable mirror image. So here these are also enantiomer. So there are a number of examples will come once we will discuss in detail in upcoming chapters, and then the chirality concept can be understood more properly, because the chirality or this type of non-superimposability in a molecule is very important during the process of chemical synthesis. So here, because the each and every products that depends upon their three-dimensional geometry or three-dimensional space arrangement of the atoms or groups in a molecule, because this makes a different type of products with different properties. So their chemical nature or their chemical behavior and other type of reaction which they gives later on are different. So these are having very importance in chemical synthesis as well as during the synthesis process. So we have to be very clear knowledge about their whether the molecule is chiral or achiral. So the chiral and achirality is very important once we are going to discuss about the different kind of reaction, their nature of reaction, and what type of the outcomes of the reaction will be. And if you are making like in a medicines, in case of pharmaceuticals, there are different isomer is being formed. So even sometime they are having the same kind of molecular formula and same kind of structure, but they having their different biochemical reactions when that type of medicine is being taken up. So here, that's why to understand the stereochemistry of that molecule is very important. So without the knowledge of the stereochemistry or without the knowledge of their uh, different arrangement of atoms in the space in a particular molecule, if it is not being aware well, then the product can be having with the same kind of molecular mass but having different nature or different reactivity. So once that type of medicine, if it could be taken up, so they having like, if you heard, like dextrorotatory and levorotatory. So these type of even different type of compounds which is having different rotation with respect to the optical light are having different properties and different reactions once it is being taken up. So here you can see are aware of that tetravalent carbon atom are tetrahedral. So this in hybridizations in your during the undergraduate programs, you might have much idea over there about the hybridization. So in Von Top and Lewell, they had given the tetrahedral structure of the carbon of the methane, especially for methane molecule they had given. So here these are the representation. This thick line represents the molecule which is above the, either it could be a molecules associated with this, if it is not methane in that case only, but if it is methane then the hydrogen, if it is the hydrogen is there, so it is above the plane. And these two weak line you can say are in plane, and this is rear side of the carbon atom. So this model and this type of arrangement is for the tetrahedral carbon is given by the Von Hoff and Lewell in 1874. Only tetrahedral geometry can lead to mirror image molecule. It means if it is having a tetrahedral type of geometry, then only mirror image can be seen. If it is in plane, then if like suppose if it is not tetrahedral, then if it is like this, so then it is bit difficult because this will be in a 2D in that case. So here it is having the tetrahedral geometry and it can leads to the mirror image in the molecule. Means one molecule is the, if once you are putting the mirror, so it will be the mirror image. If you are putting on the superimposing over here, so this will not going to be superimposed. So square planar, square pyramidal or trigonal pyramid will not work here. So especially once we are talking about the chirality, so we have to be very clear about whether the carbon is attached with the different groups or not. But this is in case of very simple type of molecules. So here you can see their rotation is different, as I said initially. there is, if the molecule is having same kind of mass and same type of atoms or group is attached with the central carbon, but even though they are having different rotation towards the light, then they could be having the different property. However, their physical property could be same, but once they will react with some particular kind of reactions, like in any kind of medicines, once we uh, took it for the treatment of any of the disease, then that medicine is inside the body, it takes a certain biochemical routes, it degraded, it acts on the body cells with a specific mechanism. So if their composition is like similar but having the different uh, rotation with respect to the light, then they will react entirely in a different way, and they will make the different byproducts. And sometimes if it is like a different rotation of light, then that will not leads to with the good impacts on the particular reactions. So this is very important to see whether they are in which form is, either is a dextrorotatory, levorotatory, so that is needs to be also addressed during the time of once any of the product is being synthesized in the chemical laboratory. So how distinguish between enantiomer? So like if in case of there are different type of projections which we will discuss in later, but here for the sake of explanation we had taken here one Fisher projection. So this is like the projection or representing of the any molecules which is having different groups in a plane. So here you can see like it could be represented like in a line structure like this way. So once you will put the mirror image, obviously it will looks like this. So how does these type of projections can be put in a form of molecule, so that it could be explained on the basis of the concept which we had discussed so far. So here you can see like here you need to just keep in mind if it is in like this fashion. So the above, this is this, if you just assume this is a one plane, so another plane is assumed as these are the rear side, these two are the rear side of the particular carbon, and these are the towards the object, like it means it is towards you, like we are just watching from here, so these are towards us because this is a 2D structure. So if you just imagine it in a form of 3D structure, so this is towards you both. So that could be if you are representing in this dash structure, so you have to represent like here these are rear side and these are towards the objects, means from where or from, or you can see towards your eyes. So this can be represented like this way. So once you will see, or once you will put the mirror in between in this molecule, so it will looks like this. So again you can see whether this is chiral or achiral. So here you can just check it out. So obviously this is not similar, so dissimilarity is there, you can say, or non-superimposable. So superimposable means if the same groups of these are superimposed with the original molecule. So this is the imaginary, because it's the image. So imaginary molecule, just imagine whether this, if as it is this is taken as or not in a form of the, like suppose this is you are just trying to put this over here, so whether this is going to be superimposed or not. So here you can see it. So similarly here with this molecule you have to first represent in this way. So here the details you can see here. The Fisher projection formula represents the two enantiomer in two dimensions with the assumption that the two horizontal bonds Cy, here you can say, uh, and Cw. So Cy, like this side, this is the carbon, this is generally not shown. So in this molecule, this center, this bisecting center is representing carbon. So this is Cy and Cw projects towards us, as I said, because this is project towards us, like Cy and Cw towards the eyes, our eyes, because we are looking this molecule. So this is towards eyes or us, out of the plane of the paper, and the two vertical bonds projects away from us behind the paper. So these are rear side, these two. So you can just understood this example with this content. You can read from here, you will find easy way how this can be represented. So another, the superimposability of the two such flat two-dimensional structure is tested by rotating end to end without raising them in our mind out of the plane of the paper. The asymmetric carbon atom is at the junction of the cross line. Asymmetric carbon means chiral, chirality. So chirality is this carbon is a chiral carbon. But once you are talking about whole of the molecules, then whole of the molecule is chiral molecule. So this is a very simple example is given here for the sake of to understand how to define the chirality, what is chirality, what is superimposability, and how does these molecules can be explained to understand the enantiomer, what is the enantiomer, because these are non-superimposable image form of the molecules. So this is by this way we understand it. So here number of other example is also given, like this example you can see here glyceraldehyde in case of glyceraldehyde, and here this is plus means a dextrorotatory and negative rectus, this is generally uh, rectus, this is represented rectus, and synergizer. So these are big terms which is representing towards the rotation towards the clockwise direction, and it is anti-clockwise direction to rotate the plane of polarized light. So here similarly another way you can see here in the example of lactic acids. So with the help of this you can also understand. So there are many more example will come once we will discuss in detail. So here the basic about the stereochemistry we had gone. So there are number of other example like tartaric acids and many more examples. So some terminology is like inversion of configuration. So enantiomer is changed into the another or other form when two atoms or groups about the chiral carbon are interchanged. So if you are interchanging, then that interchange can be like once, like suppose 90-degree rotation of the projection formula about the chiral center, or one exchange of group inverts the configuration of the orientation structure, or by the two such interchange can gives the same configuration as the first. In other words, rotation of Fisher projection formula by 180 degree in the plane of the paper does not alter the configuration. So these points are illustrated by taking the glyceraldehyde as an example. So we can see here what inversion of configuration. Here you can see 90-degree means this is the 90-degree, and this whole once you will replace this group by this, so this is total 180-degree. So here you can see by this example, and similarly one example of groups you can see here, this is another examples by this way, like you can interchange here. So you can just interchange by this, like these two groups. So another exchange of groups, another exchange. So once you will see this is can be huge model is very good tool to understand this type of conversion. So this kind of conversion can be seen by the rotation of the molecule. So rotation means with respect to this is the 90-degree, again this is the another 90-degree. So here all we discuss about the chirality and their meanings of chirality, what is superimposability, what is enantiomer, and how does the enantiomers are not superimposable to their original molecules, and for the condition of chirality is the carbon atom should have four different groups. But similarly, as I said, in higher molecules, like in case of allenes, there are due to restricted rotation, due to the rotation, because the rotation can be restricted due to the bulky groups. So in that way, that molecule will also be chiral. So there are number of ways to see the molecular chirality or dissymmetry. And achiral, as you know, this is a very simple. If it is not having such kind of conditions which fulfill in case of chirality, then that molecule will be called as achiral molecules or achiral carbons. Or the chirality can be also broken up by, if suppose the different groups is replaced with the similar kind of groups. And prochiral is another terms, also we will also discuss in another topics, and because that is the conditions which is just prior to the chiral compound. So these all we discuss today. So these are few of the references from where you can also get in more details. So thank you for your patience and listening.